Born-Oppenheimer approximation and how it is used to define an Hamiltonian operator, especially for a hydrogen molecule. That is the scope of this discussion of this video. Let's imagine the hydrogen molecule was formed. How this hydrogen molecule was formed? It is formed by the combination of hydrogen atom A which is bonded to hydrogen atom B. Okay. So this is the hydrogen A and this is the hydrogen B. So the two atoms are binded. Now because they are binded, what are all the energies are associated with it? That is the what given by Hamiltonian operator H cap. What are the energies are concerned with this one? It is concerns with the angular momentum H cross square divided by 2m. That is one energy that is associated on 2 nabba. So this delta represents nabba, delta square of A as well as delta square of B. So this is one kinetic energy associated with hydrogen atom. Now why it is given as negative? Because it lowers this energy H cap. That's why it is given. So this is connected with one hydrogen atom, say hydrogen A. Nuclei. Okay. Hydrogen atom nuclei. Likewise, there is another hydrogen atom which is in nucleus B that also to be given as minus of H square by 2m into nabba delta. It's not delta actually. This is called nabba. So nabba square 1 plus nabba square 2. I have told you earlier that the nabba represents differentiation with respect to x as well as y as well as ez. So we are talking in the Cartesian coordinate. Okay, so two nuclear energy associated with hydrogen atom, that is on one side. In addition to this one, we are also talk about the energy that are associated with electron with the nucleus. For example, so this is the nucleus of hydrogen atom and you have one electron. So they do have a attraction. Which one? These two will have a attractive energy. And this attractive energy is given by Z into E square by 4 pi epsilon R, and the distance is 1a. So R 1a. Okay, so this is R1a, where Z represents the atomic number. Likewise, there is another electron which is here. This electron is connected to the another hydrogen atom. So adding into that attractive force in the whole Hamiltonian operator, Z into E square by 4 pi epsilon naught or 2b minus of, there is a possibility that the hydrogen atom A may attract this one, this electron. Okay, so that can also be given by Z into E square by 4 pi epsilon naught or 2a. Okay, there is also possibility of attraction between this nucleus, that electron, that another electron, that also has to be added. That must be, I am continuing in the next line, that also must be to be added. So that depends Z into E square by 4 pi epsilon or 1b. So there are four attractive energy. What are the four attractive energy between nucleus and electron? This one, this two, this one, 3, and the final one 4. So these four attractive energies also been added. Everything is given in negative because of their lowering the energy. Okay, but in addition there is a possibility of repulsion. What are the two types of repulsion? Repulsion between electron and the electron, isn't it? The repulsion between two electrons as well as the two nuclei. That repulsion has also to be added. Okay, so so the repulsion between this electron and another electron, which eventually increases the energy, that is why it is given as plus symbol. The plus symbol means it will increases the energy, that is given by E square by 4 pi epsilon r 1 2. Why we haven't used this z? Because the z represents between anything, that a system that consists between nucleus and electron, but here it is only between the two electrons, and that is why the z was not included, which increases the energy. That is why it is concerned with plus charge. In addition, there is a repulsion between the nucleus and the nucleus, isn't it? So that also has to be added. So that is given as z square e square 4 pi epsilon capital R, which is the distance between the two nuclei. R12 represents the distance between the two electrons, R12. Okay, so this is the overall Hamiltonian operator to be used for our hydrogen molecule. Now here comes this Oppenheimer approximation, Born-Oppenheimer approximation. This is very difficult to solve, and that's why in atomic mass units this can be further simplified into this way. Just a minute. Into h cap equal to minus of half number square, number 1 plus number 2 square. Now why is it so? All the other values are assumed to be 1. Example, this m h cross, everything is considered and are considered to be 1, as well as this 4 pi epsilon k naught, which is a kappa, also assumed to be 1 in atomic mass units, and which will further reduce this equation to simply half into delta 1 square plus, it's not delta, I'm sorry, number 1 square and number 2 square, and they will be simplified into r1a minus of r1b minus of r2a minus of r2b minus of, I'm sorry, plus, because we have included all the 4 attractive energy. Now we're going for the repulsive energy. It becomes 1 by r12 plus 1 by capital R. So this is called Born-Oppenheimer approximation for Hamiltonian operator calculations in a simple hydrogen molecule. Thank you very much.